A new era in quantum computing, chip. Hey everyone, today we're diving deep into something huge, Microsoft's Majorana 1 chip. This isn't just another step forward, it's a giant leap toward making quantum computing practical, scalable, and maybe even portable? Yep, let's unpack how Microsoft is rewriting the rules of quantum physics. What is Majorana 1? The game-changing quantum chip. Microsoft has unveiled its latest innovation, the Majorana 1, a quantum chip powered by something called a topological core. Unlike traditional quantum chips, this one uses an entirely new class of materials known as topoconductors. Think of topoconductors as superconductors 2.0. They behave like superconductors but come with built-in quantum stability. But what makes them truly revolutionary? They enable the creation of Majorana particles, which are essential for building topological qubits. These qubits aren't just faster or stronger, they're fundamentally more stable than anything else out there. Silicon chips versus quantum chips, what's the difference? Let's take a step back and break it down. Traditional silicon chips. The devices you use every day, your phone, laptop, and smart gadgets, run on silicon chips. These chips operate using bits, which are either a 0 or a 1. That's the foundation of all modern computing. Quantum chips. Quantum chips, on the other hand, use qubits, which can be 0, 1, or both at the same time thanks to a phenomenon called superposition. This allows quantum computers to process massive amounts of data simultaneously, solving problems that would take classical computers thousands of years in just seconds. But here's the catch. Current quantum chips, like those from Google and IBM, use superconducting qubits. These are incredibly powerful, but also super fragile. Even the tiniest disturbance, like heat, radiation, or noise, can cause them to lose their quantum state, a problem called decoherence. That's why today's quantum computers are huge, expensive, and need to be kept at near absolute zero temperatures. Why Majorana 1 is different. Topological qubits explained. Enter Microsoft's Majorana 1 chip. Instead of relying on single-point storage like traditional qubits, topological qubits spread information across a quantum system. Imagine a braided rope. If one thread breaks, the whole structure stays intact. Similarly, topological qubits are far less prone to errors because they're protected by the unique properties of Majorana particles. This makes them more stable, reliable, and potentially scalable. Back in 1937, Italian physicist Ettore Majorana theorized these elusive particles. A Majorana particle is unique because it's its own antiparticle, a rare phenomenon that combines matter and antimatter into one entity. But here's the kicker. They only exist in very specific quantum states and exhibit something called non-abelian properties. In plain English, if you swap two Majorana particles around each other, the system remembers the swap. This memory effect is key to creating fault-tolerant quantum computing, where errors don't derail calculations. A new state of matter beyond solid, liquid, and gas. Here's where things get mind-blowing. Traditional states of matter include solids, liquids, gases, plasma, and even Bose-Einstein condensates. But Microsoft's work introduces a whole new state of matter tailored specifically for quantum computing. This new state allows scientists to create and control Majorana particles reliably. And why does that matter? Because these particles form the backbone of topological qubits, which could revolutionize everything from drug discovery to cryptography. With this level of power, the potential applications are staggering. Drug discovery and personalized treatments, simulating molecular interactions at unprecedented speeds, cryptography and security protocols, developing unhackable encryption methods, supermaterials, designing materials with extraordinary properties like ultra-lightweight yet incredibly strong alloys. Imagine curing diseases faster, securing global communications, and inventing materials straight out of science fiction. Can quantum computers solve everything faster? Not exactly. Quantum computers aren't universally faster than classical computers. They're only better at certain types of problems, particularly those involving massive parallelism or complex optimization. For example, quantum computers could revolutionize fields like cryptography by quickly factoring large numbers, a task that would take classical computers millennia. But for simpler tasks, like sending an email or running a spreadsheet, a quantum computer wouldn't offer much of an advantage. In fact, there are plenty of algorithms that classical computers will always handle better. So, don't expect your gaming rig to be replaced by a quantum machine anytime soon. When will we see real-world impact? While challenges remain, like scaling production, reducing costs, and testing these systems in real-world scenarios, Microsoft believes we're closer than ever to practical quantum computing applications. According to their team, we're looking at a timeline of years, not decades, before quantum tech starts impacting everyday life. What are the risks of quantum computing? Now, let's talk about the elephant in the room, the risks. With great power comes great responsibility, and quantum computing is no exception. One of the biggest concerns is encryption. Many of the encryption methods we rely on today, like RSA and ECC, are based on the difficulty of factoring large numbers. A sufficiently powerful quantum computer could crack these codes in seconds, potentially exposing sensitive data like bank accounts, medical records, and government secrets. But don't panic just yet. Researchers are already working on quantum-resistant encryption, new algorithms that even quantum computers won't be able to break. The transition to these new systems will take time, but it's already underway. Another risk is the potential for misuse. Imagine a world where quantum computers fall into the wrong hands. They could be used for everything from hacking critical infrastructure to simulating dangerous chemical weapons. That's why ethical guidelines and international cooperation will be crucial as this technology develops. Conclusion: why Majorana 1 matters. To wrap it up, Microsoft's Majorana 1 chip isn't just a milestone, it's a paradigm shift. By harnessing the power of topological qubits and Majorana particles, we're stepping into a world where quantum computing becomes robust, scalable, and accessible. Whether you're a scientist, entrepreneur, or just someone curious about the future, keep your eyes peeled. The quantum revolution is no longer a distant dream, it's happening right now. And who knows, maybe one day you'll be holding a quantum-powered smartphone in your hand. Thanks for watching, and don't forget to like, subscribe, and hit that notification bell so you never miss an update. Let me know in the comments what excites you most about quantum computing. See you next time.